Dear students, so far in the last three modules, we have discussed about various type of electrical machines. In the first module, we discussed about transformers and then about various type of motors, induction motors and DC machines. Now we are moving into the next module. It is all about control system motors. So, what is control system? If we consider different type of industries, we have to control different processes. So in that processes we will be using different type of motors for different functions. We will be discussing about that type of motors in this module. So suppose consider a paint manufacturing industry. In that there will be different type of raw materials, and we have to mix that materials in some proportions, and then we have to heat or some we have to do some activities on that raw materials, and after processing that materials the product will be produced. So during this production process we will be using different type of motor for different functions. It may be the controlling of a valve or mixing of materials, etc. So we will be discussing about that type of motors which are used in different process industries. In this module, our first topic is all about motors for regulators. So, what is meant by regulators? We know that in our home, for controlling the speed of fan, we are using regulators. Similar to that, in various industries, for controlling the speed of machines, different electrical machines, we will be using special regulators. In such applications, we will use only special machines. So we will be studying about that type of machines in this module. In regulator applications, the motors that are used should have good speed or characteristics. One example for such motor is DC shunt motor. We know that for DC shunt motor, the speed is essentially constant, but its speed can be controlled easily by adjusting the current through its field winding. So instead of DC shunt motor, if we are using a DC separately excited motor, we can control its speed easily by controlling the current through the field winding. Thus, in different type of regulator applications, we generally use DC separately excited motor. The figure shows such a control regulator application. In this, the motor is provided with a DC supply and its field winding is controlled by a control signal that is amplified through an amplifier as in figure. So this circuit is very simple. The control signal is produced by a controller in the control system, and this control signal is get amplified by the control amplifier, and depending upon the signal strength the current through the field winding varies. If the current through the field winding is higher, it produces more flux. More flux means speed of the machine reduces. If the current through the field winding is low, flux also reduces, but the speed increases. Thus, by controlling the current through the field winding, we can control the speed of the motor. Thus, for speed control application, we can use separately excited DC motor. But what is the problem with DC motor? It is relatively very expensive. We know that in DC motor there are a number of parts. It has a commutator and there are brushes and an armature, etc. So for manufacturing DC motor we have to spend more money. But when we compare the construction of induction motor, it mainly consists of a stator and a rotor, a cage rotor. Its construction is very simple and its number of parts is also very less when compared to DC motor. So induction motors are less expensive and it is also more robust. Robust means that it can be used in contaminated environment. In control system applications, this high investment cost is acceptable, but the problem is the robustness. If we are using DC motor in an industry where there is a lot of contaminants in the environment, the life of the motor will be very small. But if you are using an induction motor, its lifespan will be much higher than that of a DC machine. So, generally, in most of industries, the best motor to be used is three-phase cage rotor induction motors. The but for application in speed regulators, the induction motors have some problem. What is that? For controlling the speed of induction motor, we have to use special power electronic regulators. During initial days of industrial revolution, we are mainly using DC motors for this application. During those periods, there was not much development in power electronic industry. But nowadays, in most of the industries, we are using three-phase induction motors because of the development in power electronic industry. We can easily control the frequency of supply to the induction motor by by controlling the frequency, we can control the synchronous speed of the machine and thereby we can control the speed of induction motor. So the figure here in this slide shows a speed regulator using three-phase induction motor. So such a speed regulator mainly consists of 5 different parts. Let us zoom and investigate what are those parts. The first one is there is a converter, an inverter, and a three-phase induction motor. Then here there is a tacho generator and a control block. For this speed regulator, there are mainly two input. First one is three-phase supply and the speed reference signal. So the purpose of the speed regulator is to set the speed, output speed of the induction motor or at a particular value. So that particular value is given as the speed reference signal to the control block. For operating the motor, there should be a power supply. That power supply is the three-phase power supply. Actually, this converter block convert the three-phase supply into a DC supply. That is here. Here is DC supply, and this DC supply is given to the inverter. Inverter convert this DC into three-phase supply. That is here. So this three-phase, the output of the inverter is a three-phase supply. Its peculiarity is its frequency can be controlled. So The output of the inverter is a variable frequency three-phase supply, and it is given to the three-phase induction motor. The speed of the motor, actual speed of the motor, can be measured by using the tacho generator. So tacho generator act as a sensor which senses the actual speed of the motor, and the data is given to the control block. So what is the controller is doing? Controller has a reference signal, and the actual speed is also measured by the controller. So controller compares both of these signal. If both are same, there is no error, but if they are not same, there is an error. Controller processes that error signal and produces a control signal, and thereby it controls the operation of the converter and inverter. Actually, it controls both converter and inverter and produces a three-phase output signal at the inverter output that is at a specified frequency. That particular frequency depends upon the control signal. So, suppose the speed reference signal is 1000 rpm. That is, we have to operate the motor at 1000 rpm. Suppose the induction motor is operating at a different rpm. The tracker generator senses that rpm and it is sent to the controller. Controller compares that actual speed, with the reference signal. If both are different, there will be an error signal. Depending upon the magnitude of the error signal, controller produces a control signal and it is given to the converter and inverter. The converter and inverter block combinedly produces a three-phase supply with a specific frequency that depends upon the control signal. And depending upon that frequency, the three-phase induction motor's speed will be adjusted. That's how this block works. So this block mainly consists of converter. It converts input three-phase supply into DC, and there is an inverter convert this DC into a variable frequency three-phase supply depending upon the control signal produced by the controller. The three-phase induction motor's speed is adjusted according to the frequency of output signal from the inverter. The tacho generator acts as a sensor for sensing the actual speed of the induction motor. This speed is compared with the reference signal in the controller, and controller produces the control signal for converter and inverter. So we came to the last of our first lecture. So for speed control application, we can use DC separately excited motor and induction motor. We discussed about that. We can also use different type of motor like a variable frequency synchronous motor. In your syllabus, there is you are not studying about synchronous motors and brushless DC motors. They are not much used, but the reluctance motor you have to study about switch reluctance motor. These are also used: variable frequency synchronous motor, brushless DC motor, and switch reluctance motors. These three are also used for regulator applications, but they are not much popular. Most widely used motors are separately excited DC motor and variable frequency cage rotor induction motors. But the problem with DC motor is that it is expensive and it is also not robust. But the induction motor is robust, but their speed control we have to use different power electronic devices like converters and inverters. But due to the advancement in the power electronic industries, these power converters are now becomes much more reliable and low cost. So nowadays we are using speed induction motor for speed regulator applications most widely. Actually, in most of the industry or in industries, 90 percentage of the motors we are using are cage rotor induction motors. Now we covered the first topic in the fourth module. Thank you. Thank you very much.